Yes, good afternoon to all. Am I audible?
Good afternoon, sir. It's audible.
Okay, fine. So I am going to share the notes, right?
Okay.
Right. Is it visible?
Yes, sir.
Yes. Okay, fine. Today we are going to discuss about the corrosion topic, right? What was the corrosion topic and how to prevent that corrosion process by using various methodologies. Okay, right. So what is the
Okay,
corrosion
sir.
process? The metal that should be involved in oxidation process. Whatever is the metal that should be involved in oxidation that becomes corrosion process. For example, rusting of iron. Iron by absorbing oxygens from the atmosphere. The iron which is absorbing oxygen from the atmosphere, the iron itself undergo oxidation. That process becomes we may call as corrosion process. Simple. You have to remember corrosion process means oxidation of the metal, which is related to the electrochemistry. The oxidation of the metal, right? So whenever the metal will undergo oxidation, the process becomes considered as the corrosion process. Corrosion process, right?
Process.
Right. So we'll see some examples of this corrosion process, right? Right. Is it visible?
Yes, sir. It's very clear.
It's very clear. Okay, fine. Okay. So the corrosion process means the process of decay of the metal from its surface due to the unwanted chemical or electrochemical interactions with its environment is called corrosion. Simply we may call as the surface of the metal may involved in electrochemical reactions, especially in oxidation. That process may considered as the corrosion process, right? So here these are the examples for corrosion process. That is formation of the reddish brown layer of rust. So that is iron that should be converted into the iron oxide. So that is ferric oxide, Fe3, Fe2O3. So even some other metals also involved in oxidation, right? So the formation of green layer of basic carbonates on the surface area of the copper. Right. Here we have to remember the corrosion process means oxidation process. Corrosion process means oxidation process. Where the oxidation was takes place means at anode electrode. At anode electrode, the oxidation process was takes place. That process may considered as the corrosion process, right? So here various causes are there for getting the process of the corrosion, right? Whatever is the metal that should be available in the form of ore, like oxides, chlorides, sulfates, carbonates, and sulfides. The metal itself should be available in the form of these, right? Like oxides, chlorides, sulfates. This combined state of metal has low energy of thermodynamically stable state for metals. What is here I am going to say that whatever is the metal that should be available in the form of ore means in the form of impurities. So that may be either in the form of chlorides, sulfates, carbonates, nitrates, whatever it. From that, we may extract pure metal, right? We are going to extract the pure metal from the ore. That pure metal becomes thermodynamically unstable. Therefore, the pure metal itself involved in electrochemical reactions. By absorbing oxygen from the atmosphere, by absorbing oxygen from the atmosphere that may produce iron oxide, that process becomes corrosion process, right? So here during extraction of the metal, these are reduces, right? Pre-metal state, which is unstable. This we'll see the simple diagram. The ore of the metal means the availability of the metal in nature in the form of chlorides, sulfates, nitrates, carbonates, phosphates, like that. That all are thermodynamically stable because that is in the form of complex form, metal complexes. Further, from that we are going to extract the pure metal, right? We are going to extract the pure metal. That pure metal becomes thermodynamically unstable. That is further involved in electrochemical reactions. The surface of the pure metal may expose it to the environment, that may involved in chemical reactions, that becomes a corroded metal. The corroded metal. That corroded metal becomes thermodynamically stable. Right? Is it clear? So
Yes,
just
sir.
just just see the diagram of one diagram will be there. So here I am going to show. Right. This is the ore, right? This is the ore. Then that should be the pure metal that should be extracted from the ore. So this is the unstable. The purest form of the metal is the unstable one. The metal present in the ore form or corroded form that becomes stable. But the pure metal becomes unstable. That's why that may involved in chemical reactions, right? So this is the corrosion process, right? So here two type of the corrosion process, various effects will be there, right? So previously I showed that Eiffel Tower, right? So why means that should be protected from the corrosion process because surrounding various environment will be there, environment containing oxygen, moisture. So right, when the metal absorbs that oxygen, the metal will be involved in oxidation process, means involved in corrosion process. Till now, Eiffel Tower as will be there, means that should be prepared free from the corrosion process, right? Okay. So these are the some effects of the corrosion. So no need this. Right. Here we need to focus this. What are the types of the corrosion process or what are the mechanisms, right? So based on the mechanism, the corrosion processes are may considered as two types. One is the dry corrosion, other one will be the wet corrosion, right? One is the what? Dry corrosion. Other one will be the wet corrosion, right? So even dry corrosion may called as chemical corrosion. Wet corrosion may called as electrochemical corrosion, right? So what are the differences between the dry corrosion and wet corrosion? We'll see. Okay. Then here some more classification will be there. These all are not in our syllabus. In our syllabus, we have only dry corrosion, that is the oxidative corrosion. Then wet corrosion means electrochemical corrosion, that is corrosion by evolution of hydrogen and absorption of oxygen. Only the first one will be there in our syllabus, right? So yes, more than your syllabus is there in this notes, right? So you may check your book, right? Keep it book aside and what topics are there and the book, the only the selected topics you may read for the exam point of view. No need to go through the entire notes. Somehow excess notes is there, right? Actually, I want to reduce that. If you give time, I want to reduce whatever in your syllabus, I will make up accordingly, right? Then I will send the notes to you, right? So one is the what we are saying chemical corrosion or dry corrosion, right? Chemical corrosion or dry corrosion, in which one of the corrosion that is the oxidative corrosion. Simply, we are going to say oxidative corrosion means the metal will be involved in oxidation. Metal will be involved in oxidation that may produces metal oxides. Metal oxides. Simply see, it is brought about by the direct action of oxygen at low or high temperatures on metals, usually in the absence of moisture. The name itself, dry condition is there. There is no any moisture content. At that time, the metal will be exposed to the oxygen. At the time, metal combined with oxygen and produces metal oxide. right? The metal oxide formation, that may be sometimes stable metal oxide formation, sometimes unstable metal oxide formation, sometimes volatile nature metal oxide formation, or sometimes a porous metal oxide formation. Means a different nature of the metal oxide formation was takes place, that is depends on the characteristics of the metal, right? What are the characteristics of the metal? Based on that, that may involved in such type of metal oxide formation during the corrosion process. Okay, right. So at ordinary temperatures, metals are very slightly attached, right? However, alkali metals or alkaline earth metals, first A group and second A group, even rapidly oxidized at low temperature. The first A and second A group elements are readily undergo oxidation process even at a low temperature. The remaining transition metals are other metals, right, that may involved in corrosion process at a high temperature. So just that is a sentence you have to keep it in mind, right? So most of the metals are oxidized, right, at a high temperature only. Simple. The reactions here, reactions will be there. So just see the reactions, right? So what are the reactions means? Here, see the diagram. Whenever the oxygens are brought near to the metal atom, right? The oxygens are brought near to the metal atom. So these are the oxygens, right? So these all oxygens are brought near to the metal atom, so which may produces metal oxide. Just see here the reactions. The metal, right? The metal will be gives M plus N plus N number of electrons. That N number of electrons are gained by the oxygen. So that is converted to the O minus 2. So further, this metal plus oxygen may produces metal oxide. Now, based on the metal oxide characteristics, how the corrosion process was done, on the surface of the metal atom. So various type of the metal oxide formation is there, right? So we are going to see what type of the metal oxide formations are there, then how the metal will be involved in corrosion process, right? Next, right here, one of the parameter, that is a stable metal oxide, right? Nature of the oxide formed plays an important role in oxidation corrosion. So means whenever a stable metal oxide formation is there, simple, metal oxide was stable means further there is no involved in corrosion process. Whatever is the remaining metal will be there. Some of the surface of the metal may involved in corrosion, that may produces metal oxide formation on the surface, that becomes stable means therefore there is no attacking of oxygen to the surface area of the remaining metal, right? So here just see the picture, metal by absorbing oxygen, here stable metal oxide will be there, the bottom is the metal that may not be involved in corrosion process, right? పైన స్టేబుల్ మెటల్ ఆక్సైడ్ ఉంది కాబట్టి ఫర్దర్ దెర్ ఇస్ నో ఎనీ రియాక్షన్స్ or there is no attacking of oxygen on the surface area of the remaining metal. So that's why the metal should be protected. Only the top of the layer will be involved in corrosion. The remaining metal will be protected when a stable metal oxide formation occurs, right? Is it clear? Yes. Esma, it is clear?
Yes, sir.
Okay, further,
Yes, sir.
unstable metal oxide formation. Okay, means here also metal oxide formation is there, but that becomes unstable. Unstable metal oxide means even the remaining metal also involved in corrosion. Therefore, the entire metal may expose to the environment. That should be corrosive, right? Entire metal becomes corrosive, right? So see here, just picture, this is the metal exposed, the surface area exposed to the environment, oxygen will be there. by absorbing oxygens, right? Unstable metal oxide formation is there, right? So just wait, right? So this is the unstable metal oxide means, so this is the area was unstable. Even further, the remaining surface area of the metal may expose to the environment. So therefore, complete decay of the metal will be takes place. Complete decay of the metal will be takes place when unstable metal oxide formation is there, right? Except these, right? Silver, arum, and platinum do not undergo oxidation corrosion. Except this, the remaining metals may produce a unstable metal oxide formation. That's why the entire metal will be involved in corrosion process, right? So just see previous one. Here, stable metal oxide will be there. Stable metal oxide means only this area is metal oxide formation is there. This is the almost stable means further the remaining metal there is no involved in corrosion process. Means that should be protected. That should be protected. But this is not happen in case of unstable metal oxide formation. When unstable metal oxide formation is there, the entire metal will be exposed to the environment. Therefore, that is involved in corrosion process. So further somehow metals will be there. So that is like molybdenum. Like molybdenum. This may produces a volatile metal oxide, the volatile nature metal oxide formation. So initially the metal will be exposed to the environment by absorbing oxygens that may produce volatile metal oxide. That should be evaporates. Volatile nature means evaporate, and the remaining surface area, the remaining fresh surface area is exposed for further attack. The remaining surface area will be exposed to the environment. Therefore, the entire metal will be exposed to the environmental. The decay of the metal was takes place when a volatile nature metal oxide formation is there, right? One more type of the metal oxide formation is there. So that porous metal oxide formation, right? Here porous metal oxide formation. If the metal having pores or cracks provides access to the oxygen to reach the underlying surface of the metal. Even in this case also, the metals that should be exposed to the environment by absorbing oxygens, a porous metal oxide formation will be there. The pores or cracks or occurs on the surface area of the metal. Through their cracks or pores, the oxygen will be entered into the in-depth level of the metal. Therefore, the metal again involved in formation of the metal oxide. Like that, the entire metal may decay. Entire metal may decay. These are the four methods, right? So means four different metal oxide formation will be there. Except stable metal oxide, the remaining any other metal oxide formation is there. The metal will be undergo decay, right? This is the process of oxidative corrosion or dry corrosion. Yes, is it clear?
Yes, sir.
Yes. So here, this is spelling bed birth rule not occurs. Even not only with the help of oxygen, some other gases also responsible for the corrosion process. So that is a somehow little bit example of corrosion by other gases. Sometimes liquid corrosion, liquid metal corrosion also takes place, right? So this is also not required, means not in our syllabus. So right, coming to the electrochemical or wet corrosion, right? Electrochemical or wet corrosion. This is the type of the corrosion. Wet corrosion means just simply you people may remember electrochemical reactions was takes place. That is one is oxidation, other one will be the reduction, right? So whenever the both oxidation and reductions are takes place, at the time where the oxidation takes place, the metal will be involved in corrosion process. So with the help of that, right, that should be happen in various circumstances, right? So what are those? We are going to discuss. Okay. Just see here, this type of corrosion occurs where conducting liquid in contact with metal. When two dissimilar metals or alloys means combination of the metals are either impressed or dipped partially in the solution. Simply take one metal rod and dip in water. Half of the metal will be dipped in water. Okay. The remaining metal will be exposed to the environment, right? So at that time, what type of corrosion was that, right? How the metal will be involved in corrosion? How much part of the metal will be involved in corrosion, right? All those things we'll discuss. Then, you people remember the corrosion process was carried out at a anodic part of the metal only. Whenever the metal may act as anode, there the corrosion process was takes place. Where the corrosion process was takes place, right? So this is the corrosion process. Just see. Right. Some people are asking send syllabus. So syllabus means you people have C3 book, you may go through the book only, right? You may go through the
Sir, in books there are many subjects.
what?
So, like corrosion, there is dry corrosion, liquid corrosion, corrosion due to gas. But you told that only dry corrosion is there.
Yeah. I am saying that only. You
If
may
there is syllabus, then we can go through this.
syllabus means you have book C3 book na? You don't have book?
Yes, sir, I have book.
Yeah, go through the book. That is the syllabus only.
No, sir. There are books, but there are many subjects.
Not physical chemistry, only one book is there, yeah.
Oh, no, in physical chemistry, there is corrosion. Which one is there? After that, you told that only oxidation corrosion or dry corrosion is there. There is no liquid corrosion, corrosion due to gas. That makes
Ah,
confusion, sir.
just you listen first of all.
Yeah.
Whatever is in your book, only the topic I am going to explain. In this PPT, even some other topic will be there. That is no need, you people. You may go through the book only.
No, sir. I just want to know that if there is a dry corrosion, liquid corrosion, or corrosion due to other gases, but you are told that only dry corrosion is in their syllabus. Means their
Ah,
question will comes from dry corrosion.
dry corrosion only because you have in syllabus in your book. The remaining not in your book. You don't bother about that. Don't see and don't bother about that. I am telling what are in syllabus. You may go through that only.
The topic is there only written is corrosion. Which part is in the corrosion?
Oxidative, dry corrosion is there and wet corrosion
Liquid
is there.
corrosion, also there corrosion due to other gases.
They don't have in your syllabus. Or else remember one thing. As just you listen the topic. You listen the topic. Whatever in your syllabus, I may separate all those things. Only that PPT I can send to you. Okay.
Okay, sir.
Are why are you people are confusing a little bit? You are not kids na. That is not in syllabus. I see the syllabus. I saw the syllabus, right? So just whatever is the syllabus is there, just you have to read that one only. The remaining also there. No need to bother about that. Why you are thinking?
Okay, sir.
Here notes will be there. Otherwise, ఏ చిన్న పిల్లలకి వేస్తారేందయ్యా మీకు ఏదైతే ఉందో సిలబస్ లో అదే యాజ్ ఇట్ ఈస్ గా నేను పంపిస్తలే సిలబస్ లో ఉందా లేదా చూసి చదువుకోనికే మీకు రావట్లేదంటే ఏ మనుషులు ఉన్నారా ఓకే లివ్ ఇట్ అదర్వైజ్ ఐ విల్ సెండ్ వాట్ ఎవర్ ఇస్ ద సిలబస్ రైట్
Okay, sir.
what I am explaining you have to remember that topic only you can skip remaining topics right Are that is the book that's why some other event will be there so what we are in the syllabus we are going to discuss those things only why you are bother about that right okay just listen I don't send these notes okay whatever is in the book you may read that one only right so that's it
Okay.
Sir, sir, please, sir, don't do
no
like
no
that.
no 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 I don't send so just whatever is in the book this is the simplified only I may do some work, simplification of that work, right? Otherwise, next class onwards, whatever is in the book will be there. Just simply I may copy, that should be projected, right? Only this area I will be explained to you.
Sir,
So,
for this reason,
సార్ అలా
suppose
వద్దు
some
సార్,
others are.
చెప్పండి సార్, నోట్స్ కావాలి సార్
no,
మాకు.
no, 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 no. అరే యూ పీపుల్ ఆర్ సేయింగ్ అది లేదయ్యా మీ దాంట్లో ఇప్పుడు చాలా ఉంది అదంతా సపరేట్ చేసి టైం పడుతుందని నేను మీకు ఉన్నదే
అవును సార్,
చెప్పుకుంటూ నేను
మాకు
వెళ్తున్నా.
ఈజీగా ఉండడం కోసం మీరు చెప్తున్నారు.
దానికి కూడా మీరు
సార్ నోట్స్
సిలబస్
ఇవ్వండి
కావాలి,
సార్.
మీ దగ్గర C3 బుక్లు ఉన్నాయి, ఆ బుక్ లో సిలబస్ ఏముంది, ఇంకా క్వశ్చన్ గిందులో చూసుకొని చదువుకునే దానికి ఏంది చిన్న పిల్లలు లెక్క చేస్తారు.
Sir,
మాకు
sorry,
సింప్లిఫై
sir,
చేస్తారు
sorry.
సార్, సారీ సార్, ఇవ్వండి సార్.
ఓకే ఓకే నో ప్రాబ్లం, చెప్పేది వినండి, నేను తర్వాత నేనే ఇస్తా కదా, ఇప్పుడు ఏం అవసరం క్లాస్ లో, ఇప్పుడు క్లాస్ ఇస్
Okay, sir.
గోయింగ్ ఆన్, వై యూ
ఓకే సార్,
డిస్కసింగ్. Even I may separate whatever in the syllabus, only that thing I will send to you.
Okay, sir.
Why you people are getting tension during the class? చెప్పేది వినమంటే అన్నెసరీ థింగ్స్ అన్ని రేజ్ చేస్తారు. నేనే ఇస్తలే చిన్నపిల్లల లెక్క, సిలబస్ లో ఏముందో అవే కాపీ పేస్ట్ చేసి అవే పంపిస్తలే, అవే చదువుకోండి, వేరే ఏం ముట్టుకోకండి. రైట్, ఓకే రైట్. సో ఎలక్ట్రోకెమికల్ కరోజన్ ఆర్ వెట్ కరోజన్. ఓకే రైట్. What is the difference between the dry corrosion and wet corrosion? We'll see. Okay, right. So here simply electrochemical reactions means redox reactions. You have to remember redox reactions, and this is also happens in the presence of an electrolyte solution, right? So whenever we may pass some electricity, the electrolyte solution will be converted into the ions, right? So due to formation of ions means the electrons will be moved from one place to another place. So due to that, some of the electrode, some of the metal will be involved in oxidation, and some of the metal will be involved in reduction. Okay, so where the oxidation process was takes place, so that becomes corrosion process, right? So we'll see that this is at anode. At anode, the oxidation process was takes place. So that is the metal will be involved in oxidation. So means metal gives rise to M plus N plus N electrons. So means the metal will be loss of electrons. Loss of electrons. The metal will be converted to the metal ion. This is the process is corrosion process. Further, this metal ion will be dissolved in solution that forms a metal oxide formation. Whatever is the metal ion will be there. So that will be dissolved in solution. That is the electrolyte solution. Without electrolyte solution, there is no wet corrosion, means at least whatever is the electrolyte solution, or else a moisture content availability will be there. Moisture means like water moisture. Water is acts as an electrolyte solution. Then only the corrosion process was carried out. That is the electrochemical corrosion or wet corrosion, right? Electrochemical corrosion or wet corrosion, right? So then see. So here the corrosion due to the two phenomena. One is the absorption of oxygen, and other one will be the elimination of hydrogen, right? So this is the absorption of oxygen, then this is the evolution of hydrogen. The two phenomena was carried out, right? So which may reflect the electrochemical corrosion. So when absorption of oxygen is there, at that time how the corrosion process was carried out, or else when hydrogen evolution will be there, at that time how the corrosion process was carried out. So just we'll see. Absorption of oxygen, right? So this is anode. At anode, the iron releases 2 electrons. The iron will be releases 2 electrons. So atmospheric oxygen will be there, and water is an electrolyte solution. This is the aqueous water will be there. That aqueous water absorbing these 2 electrons, which is liberated by the iron metal, and in the presence of oxygen, that may produces OH minus. OH minus, that is hydroxide ions. So therefore, these hydroxide ions are combined with metal. Just now we are saying that the metal will be dissolved in the solution. The metal ion will be dissolved in the solution, that will be produces metal oxide. Metal hydroxides are there. So further these hydroxides may produces metal oxide formation. Fe plus 2 produces ferrous hydroxide, and Fe plus 3, that is ferric hydroxide. So this is the thing happen when the water, right? So water drops will be there, then oxygen absorption will be there. When oxygen absorption is there, at that time water combined with oxygen may produces OH minus ions. This is the reason. The OH minus ions are readily reacts with Fe plus 2 ions. The metal is converted to the metal ion. The metal ion will be dissolved in the solution, means the OH minus ions are present in the solution. Therefore, the metal ion will be combined with OH minus ions that may produces iron hydroxide. So this is the happen in the presence of, this is happen in the presence of, right? In the presence of absorption of oxygen. In the presence of absorption of oxygen. So just we are going to see, right? The rusting of iron in natural aqueous solution of electrolytes in the presence of atmospheric oxygen is a common example of this type of corrosion. Right? The surface area of the iron is usually coated with thin of film or iron oxide. So what is this means? However, if the iron oxide films develop some cracks, anodic area are created on the surface. So where the well metal parts acts as the cathode, right? So it follows an anodic area, all small surface parts, right? So where the small surface parts will be there, that becomes a anodic area. At anodic area, the metal will be involved in corrosion process. So this is the phenomena due to the absorption of oxygen. So further evolution of hydrogen. Even the evolution of hydrogen means hydrogen gas will be liberated. At that time, the metal will be involved in oxidation, that is involved in corrosion process. So what is that we'll see, right? This type of corrosion occurs in especially acidic environment, right? So the corroding metal like iron, anodic reaction is dissolution of iron, which liberates the electrons. What is the first reaction means? Acidic condition should be required. Acidic condition is required to get a corrosion of the metal, right? So then, whenever acidic condition will be there, the metal will be converted into the metal ion by releasing of two electrons. See, this is two electrons. So previously OH minus ions formation is there. There somehow H plus ions availability will be there. These H plus ions are absorbing these two electrons, produces the hydrogen gas. Produces the hydrogen gas. This acid solution may act as the electrolyte solution. So therefore, the corrosion process was carried out. The involved reactions in this process we'll see, right? So these are the reactions which are involved in case of evolution of the hydrogen. Evolution of hydrogen. Simply, iron will be converted to the iron plus two electrons. Iron will be converted to the iron plus two electrons. Then 2H plus two electrons gives rest to the H2. Hydrogen formation. Here the oxidation state here +1, here 0 means this is the reduction or else gaining of electron process becomes reduction. Both oxidation and reductions are takes place. That's why we may call as electrochemical corrosion. Therefore, the overall cell reaction is Fe plus 2 H plus gives rise to the Fe plus 2 plus H2. This is the overall cell reaction. Whenever the hydrogen gas evolution was takes place, right? So just see. So hydrogen gas evolution was takes place at that time. The metal will be converted to the metal ion. This is the process of oxidation. This is the process of oxidation, or this may called as corrosion process. This corrosion may take place in the presence of electrolyte solution. So this corrosion we may called as wet corrosion. This corrosion we may called as wet corrosion, right? So this is the wet corrosion. These two are the important for exam point of view: dry corrosion and wet corrosion. So whenever dry corrosion will be there in the examination, Just you may write about the oxidative corrosion. Where the wet corrosion will be there, just you may write the wet corrosion means electrochemical corrosion that is happened due to the absorption of oxygen and evolution of the hydrogen. Absorption of oxygen and evolution of hydrogen. Right. So here one more type of the corrosion will be there, right? So that is the galvanic corrosion. So this is similar to the Daniel cell. We already discussed Daniel cell. So the zinc rod is dipped in zinc sulfate solution. Copper rod is dipped in copper sulfate solution. These two are connected with external circuit as well as with salt grades. At that time, the zinc will be undergo oxidation, right? The zinc galvanic cell. This may explain about the galvanic cell only. Zinc will be undergo oxidation, copper will be undergo reduction. So therefore, the corrosion process was takes place at anode. Therefore, where the zinc will be undergo corrosion process, that type of corrosion or such type of corrosion we may call as galvanic corrosion. Galvanic corrosion, right? So the remaining will be there, so that are no need. So only two. What is the corrosion process? What are the types? Dry corrosion and wet corrosion. How we prevent the corrosion process are that may be utilizes with protective coatings. Protective coatings, right? So we'll see these all are not required, right? So just you may go through the comparison of electrochemical corrosion and chemical corrosion, or that is dry corrosion or wet corrosion. What we have discussed in the previous those two methods. So we can write a small pots, right? So which may differentiate. Dry corrosion means the corrosion was takes place at dry conditions only. Where the dry condition is there, there the corrosion process was takes place. Here this is wet conditions. In case of dry corrosion, corrosion was uniform, but this is not uniform. Electrochemical corrosion is here not uniform because only at anode the corrosion process was takes place rather than cathode, right? So then it is a slow process means dry corrosion is a slow process, but electrochemical corrosion is a rapid process or very fast process. It involves a direct chemical attack of metal by environment, but it involves the formation of large number of electrochemical cells, right? It is explained by absorption mechanism, right? It is explained by electrochemical mechanism, right? The mechanism of electrochemical reactions like redox reactions, right? So then the corrosion products are produced at place where the corrosion takes place. Here the corrosion products are takes place at a anode only. The corrosion was done at anode and the products of corrosive products may take place at a cathode, right? The corrosion products occurs at a cathode. Product will be occurs at cathode, but corrosion was done at anode, right? These are the differences. These are the differences between dry corrosion and wet corrosion, right? So these are the three topics. What are the corrosion? Then what about dry corrosion? Dry corrosion means oxidative corrosion. Then what about wet corrosion? Wet corrosion means absorption of oxygen and evolution of hydrogen, right? So further, some protective methods will be there, right? Protective coatings. What are the protective coatings and what are the nature of the metals, right? The nature of the metal and the nature of the surroundings. Just you may go through, read, right? So that very easiest sentences you may get idea, right? So this is one of the topic how we have to prevent the corrosion process. How we are going to prevent the corrosion process of the metal. So that is one of the method we may utilize is protective coatings method. Here also only two are there in our syllabus. That is cathodic protection and anodic protection. What are the two methods we'll see, right? We can prevent the corrosion of the metal by forcing the metal to behave like a cathode. This is the principle involved in cathodic protection. See here, just we have to keep it in mind. At anode, oxidation was takes place. Where oxidation? At anode, right? At anode, oxidation was takes place. At anode, oxidation plus takes place. Oxidation process. We need to convert this anode to the cathode. What is the principle involved in this? Means anode becomes acts as cathode. When cathode will be there, where the reduction process was takes place. Cathode the ఏంటి? Reduction process. Therefore, there is no corrosion at reduction, at cathode. So that is the principle involved in this. Two type of the protective coatings are there. One is the sacrificial anodic protection and impressed current cathodic protection. Right? What are these two methods? We will see. Right. So first one will be the sacrificial anodic protection. Right? Whatever is the matter that will be concluded or that will be given in a simple explanation. Just see the picture. Right? What is the sacrificial? The name itself will be there. Sacrificial anodic protection method. Right? Okay. So this is the what metal. We are going to protect the corrosion process of this metal. For that, what we have to do. Right? So what we have to do means we need to coat with other metal to this metal. The other metal oxidation potential will be very high compared to this base metal, right? Which metal we are going to protect, that is the base metal. For that base metal, we are adding some other metal. The other metal having more oxidation potential means that will be involved in oxidation. That will be involved in oxidation, right? So see, just take iron metal, right? So just listen. Right. Just see. Right. Is it visible?
Yes, sir.
Right. Right.
Yes, sir.
Just
Yes,
see,
sir.
this is the metal, right? For example, this is the metal. We are going to protect the surface area of this metal. For this, what we are going to do? I am using some other metal, which is more oxidation potential compared to base metal. Compared to this one, this is having more oxidation potential. Therefore, when we connect this metal to base metal, the surface will be involved in corrosion. Means the other metal will be involved in corrosion. Therefore, the base metal will be protected from the corrosion. One is the surface will be acts as anode, means the base will be acts as cathode at that time, right? So here two metals we are going to connect. One is undergo oxidation, means automatically the other will be undergo reduction. Initially, if this is the iron metal, the iron will be involved in oxidation. But some of the magnesium metal we may connected to the iron metal, the magnesium itself may involved in oxidation. Therefore, at that time, the iron will be involved in reduction. Therefore, there is no corrosion process at a reduction or at a cathode, therefore, which is protected from the corrosion due to sacrificing of anode, sacrificing of anode of other metal. ఈ అదర్ మెటల్ ఆక్సిడేషన్ లో ఇన్వాల్వ్ అవడం వల్ల బేస్ మెటల్ ని ప్రొటెక్ట్ చేస్తున్నాం. దట్ ఈస్ ద మీనింగ్ ఆఫ్ సాక్రిఫిషియల్ anodic protection. Sacrificial anodic protection. So the entire matter will be reflects this only. A simple diagram. This is the metal rod we are going to protect. The magnesium will be connected to this. Magnesium will be undergo oxidation. At that time, this iron metal may involved in corrosion process. May involved in corrosion process. Therefore, right? Is it clear about sacrificial anodic protection method?
Yes, sir.
Yes, this is the ship only, because ship always will be present in water, right? So water means moisture availability will be there. Therefore, the iron metal of the ship may involved in corrosion process. So this is the red color is the iron that should be protected. That should be protected when the other metal will be coated to that, right? So that's why the iron metal of ship may not be involved in corrosion process. The other will be always sacrificing, that may be involved in oxidation, means the iron itself may involved in reduction. Therefore, there is no process at a reduction. This is about oxidative, right? Sacrificial anodic protection. Coming to the one more, that impressed current cathodic protection method. Impressed current cathodic protection method. Okay. So what is that means? Where the anode will be there, we need to convert anode into the cathode. So therefore, there is no reduction, there is no corrosion process at a anode, right? So that is the thing. For that, what we have to do, right? So this is the method. This simple will be there, right? With the help of external battery, right? So here this external battery will be there, right? Is it visible diagram?
Yes, sir.
Yes, sir.
Yes, sir.
See? Okay. So this is the metal we are going to protect, right? This is the metal we are going to protect. This is the inert metal, means it may not be involved in any reaction. It may not be involved in any reactions, right? So these two are connected with external battery. Here battery will be there. The negative charge is connected to inert electrode, and the positive pole is connected to the whose corrosion process we are going to protect, right? So the positive charge will be connected to the metal whose corrosion we are going to protect, right? Just see here, whenever this such type of connectivity will be there. So this is the negative pole and this is the positive pole. The positive pole should be connected to the anode and the negative pole should be connected to the, so just a transformer or a reactor, right? So what is that means? This is may not involved in reaction. The electrons flow will be from negative to positive. The electron flow will be takes place from negative pole to positive pole. Whenever the electrons are coming towards the metal, so this metal may absorbing these electrons, then which will be undergo in reduction process. Therefore, itself it acts as the cathode. Therefore, at cathode, there is no reduction process. It's a simple thing. With the help of external battery, the positive pole is connected to the anodic electrode, right? So that will be involved in corrosion process. We are going to protect, that means. So the electrons will be transferred from negative pole to positive pole. At positive pole, the anodic part will be there. So the electrons, more availability of the electrons will be there. So by absorbing of that electrons, that may involved in reduction. So therefore, there is no corrosion process at a particular base metal. This is the impressed cathodic protection method. Impressed current cathodic protection method. So these are the two methods which may use it to control the corrosion process at a anode. Control the corrosion process at a anode, right? So this is the matter for this process, right? So just you may simply read. Just you may simply read this one, right? Right, cathodic protection will be there. So even surface coatings are there. So these are the not in syllabus, right? So I think last one topic will be there. That is this electroplating and electrolysis plating will be there, right? So only these two topics are there. So these two topics will be discussed in the next class. Okay. After these two topics, some two topics in electrochemistry will be left. That is Ilkovic and fixed first law of diffusion. Fixed first law of diffusion and these two topics we will discuss it, right? So this is the complete portion of the electrochemistry. After that, we may enter into the some other black, that is like either quantum chemistry or chemical kinetics. Okay. Right. Right. So whatever is the next class will be there. You people may join in the next class. Now I am going to conclude the class. I'm going to end the class.
Okay, sir.
Okay. Fine.
Okay.
Okay, sir. Thank you, sir.